Space is vast. It holds objects of unimaginable size and power. One such object is TON 618, a quasar. It lies over 18 billion light-years away from us. Quasars are incredibly bright. They are fueled by supermassive black holes. TON 618 is no exception. It harbors the largest black hole ever discovered. This black hole is a monster. Its gravity is so strong that nothing, not even light, can escape its grasp. We can detect it because of the intense light emitted by the material swirling around it. Imagine the most extreme environment imaginable, and TON 618 would still be more extreme. It's a testament to the awe-inspiring scale and mystery of our universe. Black holes come in different sizes, each with unique characteristics and behaviors. Some are just a few times the mass of our Sun, known as stellar mass black holes. Others, called supermassive black holes, are billions of times heavier. TON 618 belongs to the latter category, being one of the largest known black holes in the universe. The black hole at the center of our galaxy, Sagittarius A*, is massive and influential. It's about 4 million times the mass of the Sun, anchoring the Milky Way, but even this giant is dwarfed by TON 618. Another supermassive black hole, M87*, is also incredibly huge. It's 6.5 billion times the mass of the Sun, a true cosmic behemoth. We even have the first ever image of its shadow, captured by the Event Horizon Telescope. Yet, TON 618 remains the king of black holes. This cosmic giant weighs as much as 66 billion suns, an almost unimaginable figure. That's a number so large it's hard to even comprehend, stretching the limits of our understanding. It's a testament to the incredible diversity and scale of the universe, showcasing the extremes of cosmic phenomena. The event horizon is the point of no return around a black hole. It's the boundary beyond which nothing can escape, not even light. Once you cross it, there's no coming back. The gravitational pull is so intense that escape becomes impossible. The gravity is too strong, it warps space and time, distorting everything around it. TON 618 has an enormous event horizon. It's one of the largest known black holes in the universe. Imagine our entire solar system, the vastness of space, and the planets orbiting our Sun. Now picture a region 11 times larger than the orbit of Neptune, our farthest planet. It's almost unimaginable. That's the size of TON 618's event horizon, a colossal boundary that dwarfs our entire solar system. It's a void so large that it boggles the mind, a cosmic abyss that challenges our understanding. If TON 618 were to replace our Sun, Earth would be long gone. It would be consumed in an instant. So would all the other planets. Each one would be pulled into the black hole's grasp. They would be swallowed whole by this cosmic behemoth. Nothing would be spared. The sheer scale of TON 618's event horizon reminds us of the immense power of these celestial objects. Their influence is beyond comprehension. It's a stark reminder of the vastness and mystery of the cosmos. The universe is full of wonders that we are only beginning to understand. How did TON 618 get so big? This question has intrigued scientists and astronomers for decades. It's a question that puzzles astronomers and drives much of their research. Black holes grow by consuming matter, which can include gas, dust, and even entire stars. This can be gas, stars, or other celestial objects that come too close, or even other black holes merging to form an even larger one. Over billions of years, TON 618 must have devoured an incredible amount of material, growing ever larger. It likely started as a smaller black hole, gradually increasing in size over time, slowly growing larger and larger as it consumed more matter. Some theories suggest that TON 618 might have formed from the collision of multiple galaxies, each contributing to its growth. These galactic mergers would have provided the necessary fuel for the black hole to grow to its monstrous size, feeding it with vast amounts of material. The study of TON 618 and other supermassive black holes helps us understand how galaxies evolve and interact. It provides a glimpse into the processes that shape the universe on the grandest scales, offering insights into the very nature of our cosmos.